Let's see about runtime exception. Runtime exception are those exception which doesn't come at the time of compilation. It will come while execution of the program. So runtime exception cannot be handled at the time of compilation. What does it mean? Cannot be caught at the time of compilation. So what we need to do here, in case of runtime exception, we can have the combination of try and finally if I don't want to catch. Okay, so runtime exception, if I throw the runtime exception, caller doesn't need to catch. So if you, in case of compile time exception, we have seen that if a method throws an exception, caller has to either catch the exception or caller can throw the exception back to its own caller. Okay, but in case of runtime exception, when a method throws a exception, caller doesn't need to catch it, because runtime exception does not ask you to catch it. If you are catching, it's up to you. If you are trying to handle, if you are trying to provide some message in case of runtime exception, that you can do, but compiler is not forcing you to do anything. So runtime exception can be ignored at the time of compilation. Okay, let's see it. Let's close this test exception and create one more saying that test runtime exception. Okay, let's try to write something which will give me runtime exception. Public static void I have one method called do calculation, where I am saying that int I is equal to 1 by 0. So if you see here, this line has no problem at the time of compilation. We cannot divide anything by 0, okay, in mathematics. So if I write this one, this does not give any compile time exception. So if I run it, main method, and say do calculation, if I call do calculation, then it should throw me error. Okay, so what error it shows? So the error what we got that arithmetic exception by 0. So this is the exception which is being thrown from this method at runtime. Okay, so the program starts from here, do calculation, and it gave me problem at this line. So from print stack trace, from the stack trace we can find out where the problem is. Now it is programmer's choice to handle it. Compiler does not force you to handle the runtime exception, and it will leave the choice to the programmer to handle it. So what I can do here, suppose I am passing a divider here, and okay, so here I am passing 0. So in this method I am passing divider as 0. That's the reason I will get the exception. So what we can, runtime exception, to avoid the runtime exception we follow the validation. We can do certain validation to avoid the runtime exception. Suppose we are doing this do calculation based on the divider what we are taking as a parameter. We know that if I am taking something from parameter, there is no control what can be passed. Okay, I can pass anything from the main method. So, or if do calculation method is exposed to some UI where you are taking the parameter from some user interface, then user can enter anything as unless you provide some validation. So runtime exception we can avoid using some validation, or we can handle it properly. So if I say that if divider equal to 0, it means that I don't want to proceed here. If divider is 0, then I don't want to do the calculation. I will say that I will throw the exception. Throw the exception. So here I can throw any exception. I can throw runtime exception. I can throw checked exception. I can throw exception. So here I will throw exception. Divided by 0 exception I am throwing, because I'm throwing which is super class of which is exception, which is not a runtime exception. So what it will do, the caller has to handle it. So we need to throw this exception at method level. So if it is throwing at method level, caller, that is main method, they need to handle it or throw it exception. So right now I am handling it. I am not saying print extractors, I am just showing the message what e dot get message throws from this method. So this is the message. So I will get the message. Once I run it, I will get the message divided by 0. So it did not reach to this level. If divider is 0, it is throwing one exception, and because it is exception, which is checked plus unchecked exception, so caller has to handle it. So to avoid it, we can throw runtime exception. Okay, if I am throwing the runtime exception, I have to pass two messages. So let's see that signature of constructor of runtime exception. I have to pass the error. Okay, so if I am throwing the runtime exception, I don't need to throw at the method level, so I don't need to catch at caller level. Okay, so see the difference. When you are throwing the exception, caller does not need to catch it. So here the problem is, it is coming the Java runtime exception, do calculation, and the calculation is coming as caused by error. Okay, so here you can find out the extractors, what is happening. Okay, so what it says that if I have divided 0, generally we throw the a subclass of runtime exception, we say this is illegal argument. We say it's illegal argument exception. The divider is not valid. So when I am doing validation, I will throw the one illegal argument exception. Illegal argument exception is a runtime exception. So if I am throwing it, I don't need to provide any method label throws block, and I don't need to catch at caller label. So what it will come here, if divider is 0, it will throw the exception and come to the caller with that message. Okay. Here if you see here, it is coming that illegal argument exception, divider is not valid. Fine. So this is how you can handle the runtime exception. So I can create a custom exception also. Custom runtime exception that stands runtime exception. Okay. Once we write the constructor, I need to say super. Okay, you can write another constructor if you want to pass some message, where I will pass some message here, super MSG. Okay, so here I will throw custom runtime exception, because custom runtime exception is extending from runtime exception. It is the same impact when I called illegal argument exception. So caller has not to handle it. If caller is handling, generally runtime exception should not be caught. Okay, if it is handled by doing some validation, okay, or it is handled by the program itself. So we have to make some arrangement in the program so that runtime exception may not occur. We should avoid the runtime exception. If any runtime exception occurs, we need to handle gracefully. So if I custom runtime exception, if I extend from exception, then caller has to throw the exception or catch it. Sorry, the method has to throw the exception or catch the exception. So if my method is throwing the exception, its caller has to catch the exception or throw the exception again. So these are the options, these are the process when you try to do the handling of runtime exception. Okay, now let's see few other things. Now if I pass divider 1, there should be no problem. My program should run fine. I'm not doing any print, so let's try to print the result. Sys out I. Okay, I say I is equal to 1 because my divider is 1. If my divider is say 100, I will get the value of that. Here because I have taken integer, so it will give me the integer value of that result. Let's put it as double so that result will come proper. Okay, so this is how we got the proper result. Now let's try to see some other exception. So if I say string s is equal to shiv dot substring 0 to 100. So we know that substring will give the part of that string provided from start and ending index, that is 0 and 100. So here we know that we are giving an index which is more than the length of the string, which will create the problem. So once I run it, it should give me some exception saying that array bound of exception or length is more. So it is say the string index out of bound exception. The problem is coming on this line. Okay, so this is also a runtime exception. How to avoid it? We can say that suppose I am passing here length, say end index equal to 0. So if I say if end index is more than, let's take this variable also, let's given a string equal to shiv, so that I can reuse this variable. Whenever you see that there is you are trying to find out when you are trying to use a few section of the code many times, you can make that section of code into a method. You can wrap that logic into a method so that that method can be reused. And if any string or something which you see that is being used, you can create a variable on that string so that that variable can be reused. So every time you don't need to provide the string here. So here the situation, I need to find the length of this string. So I will say shiv dot length. rather of doing that, we will create one variable, say given string equal to shiv, and we will use this variable wherever we will need. So we say that given string dot substring 0, if end index is more than length minus 1, then we have to take till length minus 1. Otherwise we can use the end index what user is providing. Okay, so I say string s is equal to given string dot substring start index is 0, end index we don't know what user can provide as a end index. So end index, let's take this one from parameter, for example. Okay, let's do one thing, let's create one more method, because it seems very confusing to provide the arithmetic exception and string bound exception in the same method. So let's do one thing, let's move this code here, and here I say do substring. Here I am passing end index. Okay, so now we don't have control on
parameter what user is passing from outside. So we are controlling from here while doing the substring. We will say that if that end index is more than length minus 1, if it is more than last index of the string, then if I try to use that end index, it will create that kind of problem. So in that case, I will use only given string dot length minus 1. If it is less than that, we will use the end index. So if I call this method do substring end index, I am giving 100 here. So it will not do anything. It will not throw any exception, but it will not do anything. So what it will do, it will, let's print the value of s. It will not, yeah, it will print the value as shi. Okay, so here the length is 0 to, because end index is more than 100. So here we will give 0 to given string dot length minus 1. Okay, so let's debug this program. If you see here, end index I am passing 100, given a string is Shiv. Here if you see that given a string dot length minus 1, what is the value of that? That is 3. Okay, so because length of the string is 4, so it will say that 3. So because this end index is greater than given string dot length minus 1, so that is true. So it will do the end index as given a string dot length minus 1, otherwise end index. Okay, so s will become shi. I am wondering if I say sys out here given a string dot substr 0 to given a string dot length. Okay, so this one it should give me the value as Shiv. So here we will take till length. Here also we will take till length. So here if you have seen that the end index what I am passing here I am controlling. We know, so these are the whenever you do the coding, you can avoid the runtime exception by the way you do the coding. Okay, so here we know that an index can come more than the length of the string, so we have avoided the issue here. Even if I pass value as 1 because it is less than the string length, I will get the actual value. But if I pass anything which is more than the length of the string, then I will get that maximum, that is length of that string. Okay, so this is how you can handle. So here runtime exception we have handled using the way we do the coding. Okay, so this is from the this is how a programmer should write a program to avoid the runtime exception. If you foresee any runtime exception, either you can handle it or you can throw to the caller. If you are throwing a runtime exception to the caller is not forced to catch it. Okay, so there at the compile time there will be no problem. But if you are throwing the exception, if caller is not doing so, caller you will get the stack trace in your log, in your console, and program will break because it has thrown one runtime exception, which is not caught gracefully. So I hope you have understood how runtime exception work. Let's see something more on runtime exception for null pointer exception. Null pointer exception is the exception when you are trying to access any operation on your null reference. Suppose you have some string called string s1, okay, dot null. If you print this string s1, you will get the value null. I am calling this same method to substring. I am trying to change in this method only. So what if I try to do some operation, say s1 dot length, because it is a null. When you try to access any method on that, any operation on that, then it will throw you null pointer exception. So null pointer exceptions are very common exception when you do the coding. So null pointer exceptions need to handle because it will give you runtime exception. Null pointer exception comes when you are trying to access some operation on any object which has null reference. Okay, so how to do that? How to handle this kind of runtime exception? So what we need to do here, we need to do the null check. So we can say that if s1 dot s1 not equal to null, then only it print the string, otherwise I say 0 length. So because here string is null, it will print 0. So you can handle this null pointer exception by putting this condition, if condition s1 not equal to null. Like any object, say if you say object ob, so ob not equal to null, so that will help you to avoid the null pointer exception. It is not necessary to handle the runtime exception. Sometimes there is maybe situation that you let program through the runtime exception, because that is caused by outside environment of the method. Okay, if you don't have any control, if you're not seeing any possibility to handle it, there is a lot of uncertainty on the type of data what user is passing. If you're not sure what to handle, then you can leave it. At the time of compilation, it is not required to handle it, to catch it or handle it. So it's always programmers smartness, or based on the situation, based on the what type of logic you are writing, you can choose the option of catching and handling it, and you may not. Okay, so suppose you know that this s1, for example, s1 there is I'm making it null. If I take this parameter from index from method, if I'm taking this one from method parameter, and if I'm sure that this value cannot be null. Okay, suppose this value is coming from some database which is marked as a primary key, which from one column from database, that column is marked as primary key. So primary key cannot contain the null value. So if any value is coming from that column as parameter, we can ignore the null pointer check, null check. So because we know that source of data is cannot have null value. So during that kind of situation, you can avoid this null check. But if there is any possibility of getting the value as null, which you are aware, then you should do the null check. Okay, suppose you are having two string here, and I say string s2 equal to Shiv. Okay, so if I do something like this, if I say s1 dot equals s2, here I am sure that I will get null pointer exception because s1 is null. Okay, here if I run this program, I am sure that I will get the null pointer exception at this line. Okay, because s1 is equals. So there is, if you are trying to compare, two strings or two objects, and one object is constant. So here s2 is constant. It can never be null because we have defined here. So in that case, we can reverse the check. Here we have handled null pointer exception without null check of s1, because here it will do the equal check for s1 and s2, and equal operation is performed on s2, which is not null. So parameter can be null, but operation on null reference will always give you null pointer exception. So to avoid whatever, if you are trying to access any operation, then make sure that that variable is not null. So here s2 is not null, so I can do s2 dot equals s1. I could do similar thing, saying that s1 not equal to null. Okay, so s1 not equal to null and s1 dot equals s2. This is the same thing, but this is something extra code. Okay, this is extra code. This can be avoided simply saying that s2 dot equals s1. Okay, in this case I will not get any error. Fine, this result is of this is out. So this is all about runtime exception. Let's try to see something more about public void check nested. Let's create another class for. So basically I want to show you how to do the nested try catch. Okay, let's create one more class. Test nested try catch. So nested try catch means something like this. If I have a method public static void test. Okay, so I have some method here. In case of throw catch and throw example, you have seen that if there is a exception in a method, I can throw it, so caller will handle it. If caller is not handling it, caller will throw, and caller's caller will handle it. So it is kind of chain of exception. So sometime in your project you may need, suppose you may need this kind of handling. Suppose you are on the controller layer, then you are calling service layer is calling another service layer, and that service layer is calling another data access layer. So if data access layer is throwing some exception and you don't want that exception to if you want that exception to be propagated to the UI level, so what you need to do, you just need to throw that exception back to the service layer throws that exception back to the another service layer, and that service layer throws that exception to controller layer, and controller layer will catch that exception and from a proper message from that exception, which is really helpful to understand to the user who is using that software. So that way they can provide the message to the user interface. So exception can occur at any layer. Okay, and it's good to do the validation on the front layer itself. So it could be controller layer, it could be UI plus controller layer. So wherever possible, do the validation to avoid the exception in the inner side. Okay, so early catching of the exception is always good. As soon as you catch the exception, throw it back or handle it based on the situation, based on the type of the logic what you are writing. So you can do that. Okay, let's try to understand nested one. So here so far we have understood that it is a chain of the exception handling. So innermost logic is throwing some exception and caller is doing it. So this is like from one method to another method, and from another method to another method. Nested try catch is the example when you are trying to do the exception handling in a same method where you are propagating the exception from bottom layer to top layer. So something like this. If I have try catch okay, inside this try I have another try. Okay, inside this try I can have another try. Okay, if you see here I have three level of try. This level, and this level. Now if I am doing some, and to remember that we can write try block in anywhere. So inside try catch, inside the catch block also you can write the try. Suppose you are catching some exception and you are handling it. So while handling it, you are writing some logic. So while writing the logic, there could be again exception that can occur. So inside catch you can write something, try catch here also. Okay, so these things you can do here. If you are doing this one in case of try catch inside this catch block, because we know that the scope of this exception is till this section. Okay, so you cannot redefine the exception again variable, so you have to use that another variable. Other than that, if I use this catch block, the scope of this is inside this block, the scope of this E is inside this block, the scope of E1 is inside this block, okay, and the scope of this E is inside this block. So that way you can understand the scope of exception variables. Okay, let's remove this one, because here we are going to understand about nested try catch. So here I say that int I is equal to 1 divided by 0. This is very fair runtime exception. Okay, so if this exception comes, of course, because we are handling it, it will come to catch block. Okay, so if I am printing here inside label 3, okay, then I will throw it. Okay, I will throw this exception. So this try block, it throws the exception and which is caught here, and while handling it I have done one sys out, and that exception I am throwing it back. So this block is throwing the exception back to outside. Here outside is another try catch. Okay, so here what is happening, this portion is throwing the block, okay, and we have catch block for this try also, so it will come here. So if I say sys out inside label 2, okay, here what I am doing, I'm throwing it back. Okay, so here what is happening, this section, it has got the exception and caught it, and while catching the exception it just print one line and it thrown the exception outside. Here outside is again a try block. Okay, if there is no try block, it will throw at method level. Because there is try block, it will come to its catch method if it is written. Catch block is not needed when you are throwing the runtime exception. Here catch block is needed because you are throwing the exception. Okay, so we need that catch block. So in this catch block I am saying that inside label 1, and after that I am not throwing. So if I run this program, so I say main method and say something test, call it. So if you see that first it came to label 3, then it came to label 2, then it came to label 1. So in label 1, while handling it, if I throw it back, then it will be thrown at method level. So at method level I have to say either I will catch it or I will throw it back to method level. So if I am throwing it method level, it is again same thing which I already explained. You have to either catch in the caller or caller can throw it back. So there is endless story. So there is no end as long as you are throwing the exception. Finally it will break the program and write into the console. So to avoid the breaking of program, you need to handle it. Okay, fine. So this is how nested try catch block works. So we have seen that the combinations let me open that where we have written combinations of try catch. So here try plus catch when code in try block throws checked exception, means compile time exceptions. Try and finally when code in try block throws runtime exception, throws unchecked exception. Okay, and try catch and finally we can write in any combination if we want. Okay, so finally is used when you want the program, when you are trying to release any resource. Suppose you are making one connection. After making database connection, after making the connection, you are trying to fetch some data from database. While fetching the data from database, you got some exception, but connection is already made. So when you get the exception, it will come out, that is runtime exception, and that exception will throw that block will throw the exception and program will break, but your connection is still not released. Okay, so for those kind of situation, when you will need to write finally block to release those resources. Okay, so because we know that finally block will be always executed unless you use the system.exit, okay, from your flow. So suppose you have some try block and you have written some system.exit. So after executing of try block and system.exit, it will come out of method. It will not execute the finally. Otherwise, it will always execute the finally block. Okay, so this is all about exception handling.